Here's an insightful conversation I had with Matthew Carli, the Director of Innovation at Laticrete, a company that specializes in materials.
Hey, Jarrett.
Hey, Matt. Uh, Here we go. Can you see me now?
Yep. Yeah, good afternoon.
All right, how's it going?
Doing well. Beautiful spring's finally come here in Connecticut.
Yeah, I'm in the East Coast too, so we have similar weather today. It's been a really nice past few days.
Yeah, I think the world's hopefully they still remember about coronavirus. It seems like everyone's just hopping out of their shell over here. So
Yeah, slight return to like inching towards normalcy, maybe.
I think Texas opened up today. Georgia and several other states, or whatever they define as open up. I don't know. So
Yeah, I'm
each state
happy
has different
about
rules.
Texas opening up. I'm trying to go down and see Icon's project there as soon as I can.
All right, go down to Mexico.
Yeah, I'd like to see that project
Okay.
as well. Mexico is a little bit more of an adventure than Texas is right now, but yeah, I'm gonna start with the project that they're doing in Austin. I think hopefully within the next 2 months, we'll see.
Yeah, I haven't been down there. Actually, I was supposed to go my first week of self-isolation.
Uh-huh.
Our scientists visited with Icon that week in early March, I guess. But yeah, the operation looks impressive. I mean, full warehouse, full staff, really dedicated to the mission. So it's cool to see such a really well-rounded startup in the space.
Yeah. So you're the director of innovation at Laticrete, right?
Yep, correct.
Can you go into a little bit of detail about what that position is about?
So sure, yeah, I guess starting better start with who Laticrete is. So 65-year-old family-owned business based in Connecticut. It's a global company, so we manufacture and have business units around 20 countries globally. Um, the name Laticrete comes from latex plus concrete. So is the founder invented a new way to install tile adhesive or revolutionized tile adhesive to make it a thin bed adhesive. From that, the company kept growing, expanding, taking that technology globally, looking at making basically everything you need for tile installations: waterproofing membranes, sound control, the grout, etc. And then over the last 10 years or so, the company's been expanding into other areas. So resinous flooring, concrete additives, sealers and cleaners for natural stone, masonry veneer installation systems. So the product width has definitely grown over the past 10 years or so through acquisition and through organic development as well. In addition, the global expansion is definitely a goal of the company. So we're a market leader in several markets around the world, and I started with Laticrete about a little over 7 years ago. In a program called Management Trainee. And basically, my role has been unique in the company. Even innovation is a core value, but about 3 years ago or so, we started looking into a project we called the listening post. So I'm getting to the point of what director of innovation is. It's basically twofold. It's one side is process improvement, a change agent, internal consultant within the company to make sure that that core value of innovation is upheld, that people are pushed and critical questions are asked, and that we continue to focus on process improvement and continuous improvement. The other side is looking towards tomorrow. So building the strategy of hedging our bets with something like 3D printing. So we have four main focus areas that we look into. Digital is obviously a main component of that. So connecting everything in the tech stacks of our customers, from supply chain through specification, procurement, and helping them track projects and then install better. So everything in the digital sense is a major focus of ours. Automation is something we see coming into the construction space. So just when you look at our products, how do we automate them? So robotic application of existing conventional products. And then this idea of digital fabrication stems from that. And then that's where we get 3D printing. So you know it very well that it's the first real digitally native construction method out there that requires everything to ask the question of constructibility at an early stage. So we're really looking at 3D printing to help us lead towards our digital transformation. And then continuously looking at new materials and integrated supply chains is also part of that future vision.
Yeah, so it sounds like a pretty all-inclusive definition of innovation. So you're looking at not only the similar to like material science is a primary strength of Laticrete. And so obviously all the material scientists are always looking for ways to innovate the materials, but you're responsible for innovation not only in the industries that you're covering, but also in the way you do business. And I guess maybe some softwares and some like people management techniques even. And then also places of future business where Laticrete could potentially expand in the future. So yeah, I think that gives a pretty good general idea of what your position is. I'm curious, being in that position in the contemporary kind of work from home environment, are there innovations that you had maybe on the back burner that have been brought forward in this time to help people with working from home and stuff like that?
So working from home, I think the biggest single thing right now, top of mind at Laticrete, is our internal processes. So we've been auditing them. We've been switching over to integrated software, so Office 365, and basically just a holistic improvement of all the communication channels and inner workings of the different departments. So we were in the process of rolling it out here before COVID-19 hit. And the really cool thing that I'm really proud that Laticrete's done with this is we didn't just mandate exactly how we're going to do it. And it's been a very iterative process with the entire company to allow them to make mistakes, to allow open, organic adoption of this software. And so we've already seen just vast improvements in communication. Everybody, basically, if you're not on Office 365, you're not on Teams right now, you're kind of not seen. So we've really replaced the physical office with our digital office rather quickly. There was kind of a week lull or two where people a little shell-shocked, and now we've quickly, some of us might even question what the regular office looks like anymore, or to what extent it's going to be needed. So
yeah, certainly. I had experience with a job that I had once in construction management at the Federal Reserve, where they had some great software and they were going to give people iPads in order to implement it. It would get rid of a lot of paper processes that were taking up too much time. But despite all the efficiencies, people were stubborn in their ways and they didn't want to initially switch over. But now, I mean, I'm not at that company anymore, but I would imagine that they've kind of been forced to switch over. And so maybe from your perspective, it's almost a relief to have people willing to now use these new technologies that have been available.
It's, yeah, I mean, depending on where you sit. So we've definitely seen an impact of sales. Fortunately, construction is still an essential business, so it hasn't fallen to zero. Some key markets were hit harder than others, like New York and Boston. But on the, let's say, the e-learning side, so Laticrete was an early adopter with e-learning. One of my colleagues actually reported to me before Steve Rampino with Laticrete University. So he had been building it out over the past 4 or 5 years, and we have over 100 modules ready. So something like that was just the timing was perfect because we already had all the infrastructure in place. So it wasn't even a matter of flipping the switch. The switch was already flipped. It's just getting the adoption. So we've seen doubling, tripling of the users coming to our e-learning platform. So yeah, it's a blessing and a curse, but there's definitely things that, webinars, for example, we have a captive audience. So it's amazing to see just how many people tune in and the level of engagement. We hosted a 3D printing webinar, our colleagues in Singapore, and amazing to see just the interaction. Like what I've typically experienced with webinars has been very passive, that people kind of keep it in the background, but we were getting questions the entire time. And after we're able to download all the questions, send it out to the entire subscriber list. So it's just, there's definitely some benefits and adoption that would have taken years and years for people to come around to, just out of necessity here, picking it up and saying, it's not that bad. So it's pretty cool actually to see.
Yeah, there's definitely some silver linings for people who are looking hard enough for them. Yeah, so how did you first learn about 3D printed construction, and like where did you personally first get an intrigue for it?
So it happened about 2.5 years ago or so, 3 years ago, that just starting to look into new technologies, what's happening. And there was some talk of 3D printing at Laticrete for years. And basically I picked up on the project. It needed let's call myself a project manager at the time.
Sure.
And it was maybe about September or something, and I came up with a short list of 10 people that I was looking to connect with. That was the world of 3D construction printing in September 2017 or something. And I found this event that Henrik van Loosen was having in Denmark. And basically my entire short list of everyone I wanted to talk to was at that event. And from there, it's just really accelerated. It's the adoption of it, the number of people interested in it. Speaking about 3D printing, it's just, we've gone from 10 people on the short list to now hundreds, and major companies of all walks coming into 3D printing. So it's amazing to see, just from architectural world, from structural engineering, from materials, robotics, basically everybody's looking into it. It's been a really cool journey.
Yeah, I think that any forward thinker can tell there's some major innovations that are going to take place in construction, leaning towards automation and efficiency and increasing the value per worker, like a lot of other industries have seen. The question remains open how that automation will take place necessarily. I like the idea of 3D printing, but like ultimately we'll see if it turns into that or some other kind of apparatus. It's really cool to talk to you from a materials company perspective, because most of the companies I've talked to are more worried about like the hardware of their technology, the robotics, maybe the software. And a lot of them have specifically said the material is such a big challenge in and of itself that they're leaving that to the materials experts, and they're not even touching that and just waiting for the material developments to happen over time, while they really focus on improving their printer, the print speed. And I know the pumps have been a really big problem for people as well. So can you tell me anything about the developments that Laticrete is making in the printed construction space for materials?
Yeah, for sure. So I guess first of all, materials are nothing without the hardware. So they definitely work hand in hand, and it's not that one side can solve this equation. The materials we've been developing are also based on parameters of what's been coalescing as the normal in the construction space.
Sure.
So example, we went to Dubai and looked at the I think it was about 5 printing companies in Dubai at the time, and all 5 of them were using the same mixer pump configuration. So quickly we had a formula that had already developed in our lab, and in the lab setting we had no issues. It works well. But then the water ratio and output of the mixer pump that was being used in Dubai, I can share, it's the MTech Duo Mix. So that was kind of the standard. So then we quickly set that as a new parameter and developed a formula that works with the MTech with the more robust water ratio. So you can go from a lower to a higher percentage of water by volume, and still the material will function as is. So we're constantly evolving and working with different printer companies. So still, there's still a lot of really open, big questions with 3D printing. Is it going to be on-site, off-site? Are we doing prefabricated components to replace precast? Are we making Lego blocks? Are we doing this on the job site? And all of those come right back to materials. So if we're talking about 30 seconds between layers, are we talking about 2 minutes between layers? Are we talking about the thickness of the different aspect ratios of the filaments, degree of overhang, degree of precision, the aesthetics, looks of the materials? So it's again been this really fun iterative journey, and each project we've had to kind of tackle individually. We do have our opinions of where we think the material market's going, and some things we're proud of is just we've seen lately with getting materials sampled in more and more printing companies, how quickly we're able to calibrate to the new printing configuration, oftentimes without even an R&D specialist on site. So that's a huge improvement that the printing companies are basically able to take our one component system and follow an instruction of how to mix it and be able to produce beautiful prints. So without high speeds, no air bubbles, or complex designs, beautiful aesthetics. So we're again, it's still a work in progress, but we've been seeing a nice trend line, if you will.
So the benefits of increasing the amount of water you can have in the mix, I guess that increases the flowability and the viscosity?
Not necessarily. So we had a material that was under 10% water. Okay. And if you look at some of our highly engineered materials like our self-leveling, the water ratio is very low. It's just an engineered mortar. So you have a lot of plasticizers in there that are really making it flow. Again, it's this equation of what are we trying to solve, and making sure the parameters align correctly. So if we want a certain amount of shrinkage, if we want no slump, if we want this or that, we need to make sure that we're hitting this within the price point. So in the concrete world, water is often referred to as water of convenience. So at a certain point, yes, you're going to add extra water, and then you can get flow properties. When you're pouring into a horizontal pool, a containment, shell, a foundation, that water has time, it has structure around it to let all the water escape from the system. So it's not such a concern. But with 3D printing, we're entering a whole new world that even some of the cement scientists, so I guess also caveat here, I'm not the technical expert. I'm more from the business side, but we're looking at new parameters in testing of concrete or cementitious mixes that have never been looked at. Nobody cared what it was performing like at 30 seconds, at 1 minute, at 2 minute intervals. The interval of testing was, okay, maybe you had a slump test initially, and then when can I walk on it? And 1 day, 7 day, 14 day, 28 day cures. So the whole testing behind, how is this material performing? It's basically carte blanche. It's a whole new approach to what are we doing.
Yeah, that's a fascinating perspective. I guess it really zoomed in on like the micro of the minutes and the seconds and how long it takes to be able to print the next layer rather than how long the electric guys can come walk on the slab to install whatever. But so have you included latex in those mixes?
So I can't really speak to the additives or the
Sure.
composition of the formula. Um, we can speak to the properties. So latex does give flexibility to the mix. That is in the mix. So there's properties that the latex will bring that our material has. And when we're speaking about the mix right now, again, I would classify it as completely over-engineered. Our biggest goal right now with 3D printing was make it work. So that's what we did. We developed the material to work with the conditions. So everything was contingent upon which partners we're working with, the hardware, and what they were trying to achieve with the material. So is it working? 100%. It's able to go through those apparatus and apparati and actually perform. What the composition is going to look like in the future is most likely going to change, but we're growing together with the industry here.
Yeah, certainly. I guess a big part of being over-engineered maybe is the cost. So it sounds like what you're getting at is the current models, you were just trying to make the most perfect version of the material that you can, with cost not being the primary issue, just demonstrating that you can use the product because it's such a low volume need for the product right now. Once the demand becomes much higher with economies of scale, now that you know what the right mixes are, you'll be able to scale up and decrease the price to make the mix. So it makes a lot of sense for me that at this stage in the market, you guys are working on creating the most efficient solution and working from there to figure out how to make it cost effective for mass market. I mean, there's definitely time to wait for this technology to become mass market because the companies that exist, like you said, there's dozens at this point of companies with printers, but none of them are getting residentially permitted houses yet, America or elsewhere. So it's not like Laticrete needs to have a cost-effective material solution right now. In fact, it would probably be harmful to put something like that out when you can wait another 2 years till they actually have a bigger need for the product and release something that you guys are more confident in, more tested, more proven.
So this concept of cost and mass market, I've been hearing a lot about the term, or the question has been asked many times now, when is it going mass market? My initial thought and rebuttal on mass market is 3D technology in other areas is barely entering mass market. And by mass market, I mean the main way you produce that product.
Yeah, sure.
So if you look at something like where 3D printing is being used in other places, it's one-off unique things like dental implants, prosthetics, prototyping in the automobile industry or something like that, right? So the biggest challenge with cost effectiveness in construction is what do we benchmark against? Uh, right now, I don't know if we're at a point where we can say that 3D is this, silver bullet solution that's going to be used across the board. But what I'm bullish on is that it's forcing the question again of constructibility. So when you go to a project and you say, I want X, right? So I want a home and it's got 4 walls, but I also want this breakfast nook. So if we had all the proper data and analytics in place, you would easily be able to say, okay, well, I can add you the breakfast nook and it's going to be 3D printed because 3D printing is a less expensive option to do that customization and curved walls and really unique design. But for the other straight walls, we're going to do pour in place concrete or CMU block or timber frame or something, right? But the benchmarking to easily like a, what's the word I'm looking for, plug and play solution to just switch out and say, oh, well, the breakfast nook's going to be 3D printed. We're not there yet with the conventional. So it's hard to just substitute out the 3D printing solution. There's also this idea of convergence when we're talking about cost. So right now, a mortar is always going to be more expensive than the pour in place concrete. But also, what are we comparing to performance-wise of strengths? And if you look at compression strength, we're exceeding 5,000 psi, where most of the concrete going into the rest of the structure is probably in the 3,000 range. So there's different apples to apples comparisons that we need to get to when we're talking about cost. In addition, we need the approval, the code recognition, the allowance to put in 3D printed buildings, but also rely on parametric designs that's going to give us a regenerative designs. It's going to allow us to have less material, but a more expensive premium material, less of that than conventional. But right now what we're doing in 3D printing is making concessions to get projects. So we say, okay, for this project, we want to build the house in wherever. We go to the local jurisdiction and they say, okay, well, mimic CMU block and you can have your permit, or be outside this, or make your wall thicker. Again, over engineer it. And you're seeing that on the structural engineering side as well. Talking with a structural engineer, he said almost always you'll see that in residential construction, if you go to a structural engineer, so there's two codes. He said there's international residential code and international building code. For an IRC home, you don't need a structural engineer to sign off as long as you follow the protocol. But if the structural engineer signs off on it, and you want a structural engineer to design it, more likely than not, is, in his opinion, almost always, that's going to be way in excess of the IRC, and even in excess of what's needed for the ambient conditions that wherever the house is going.
Sure.
So we're trying to still compare this premium one-off product to, and no disrespect to you, it's kind of a question we're struggling with ourselves. Is the benchmark is on the mass-produced track home, and we're making luxury premium one-off homes and trying to match the price and say, okay, this is the same product. But with 3D printing right now, we're not there yet. We're still at the premium one-off luxury home.
Yeah, I agree with that analysis 100%. It's interesting to see as it progresses. Like, a lot of people want to see it pushed out in places that really have a big need for affordable housing, but you can't hit those places until the economies of scale really kick in. And so the one-off applications where people are getting particular design requests that can't be fulfilled easily with other methods, that's definitely where the beginning is going to, that's when it's going to shine. I had a conversation with the founder of one of these companies a few years ago, and they told me that their strategy is similar to Elon Musk's with Tesla. So first they put out the high price model that's really nice, and it kind of like shows the market what's going on. And then after they establish that, they kind of put out like a more lower price model years down the future, and then they're able to keep up with the market demand. It's like there's definitely a big difference between a luxury product that people want and like an affordable housing solution. And I guess it's to your point that it's not really a mass market yet. Until you hit that affordable housing solution, then it's not really going to be like an enormous portion of the business that your company's doing necessarily.
Yep. Yeah, I agree 100%. The social housing, affordable housing is definitely something where 3D's a promising solution. It's promising for many ways. When you look at, again, the natural disasters that are happening, just adding insult to injury here with what's the need for affordable housing is already dire in many places. And then add wildfires, add hurricanes, add everything. So the premium product or the lower end of the Tesla product is still a beautiful product and still a better product than most basic cars at the same price. So I think I'd love to see something similar with 3D, where that these affordable homes that people are receiving are in many ways better products than what the comparable alternative was in the past. And I'm a believer that we'll get there. That's it's very, very much achievable. We know. I like to share the picture in Florida there of Mexico Beach, where the hurricane came through, and the one guy that built his house, not looking at code, but built it to what he believed were better materials. It really showed that we have the technology, we have the expertise to do and make beautiful housing products that will stand the test of time. But getting them at the right price point and getting them in the system, this is something that's still needed. So as 3D printing becomes more push button, easy to operate solutions, we'll be reaching that lower end as well.
Yeah, that's a great point. Like whether it's push button, how close it is to push button. When I first got interested in 3D printing construction, I bought like a regular 3D printer, a desktop one, and assembled it myself just to figure out how it works. And so many prints, like less than half of them work with the first push of the button, in my experience. So sometimes you have to either adjust the first layer or wipe down the board or something. Like there's always some issue that pops up. And with something as big as a 3D printed house, you don't want that to be halfway done and then all of a sudden have some error or something that's tricky to mitigate. I definitely would be curious to see. I've never seen one in person, but it'll be interesting when I do, how they deal with the little issues that come up, because concrete is a much harder material to get rid of than a little piece of plastic the size of your hand.
You converted the desktop printer to cementitious mortar, or
No,
you're using thermoplastic?
just PLA, very basic.
Okay. So we for fun, our scientist there, Covarian, he converted a desktop 3D printer to use our mortar as well.
Wow, what printer? Do you know what he used?
I'm drawing a blank on what it is. I forget the name of it, but it's a basic, $200 3D printer.
Sure. Wow.
Hooked up an extruder hose and basically just circumvented the heating element and has it drop straight in, but the XYZ plotter remains the same.
That's really cool.
And yeah, so I mean, right now we're dealing with really fine aggregates, so we're able to. I think the basic rule of thumb, if I remember correctly, as long as your extruding nozzle is twice as wide as your thickest aggregate, I think it's twice. I have to double check that. But as long as you're twice as thick as your largest aggregate, then you're fine. So, we're under, let's say, 3 millimeters of diameter for our aggregate. So then you're talking about a potential to 6 to 10, it's 1 centimeter extruding nozzle can easily be done on that desktop printer.
Which allows for a pretty fine level of detail if you're down to 1 centimeter.
Yep.
That's really cool.
So he's built some fun spiraling towers and overhangs and everything.
Do you know anything about the waterproofing capabilities or water resistance of the materials you developed?
We haven't tested the material itself for how impermeable it is. It's still a cementitious mortar, so there's still going to be some wicking, some absorption of water.
Sure.
It's definitely not an impermeable material, but we have tested how well we produce latex-based waterproofing as well, our hydroband system. So our hydroband will adhere directly to it. It can be an air barrier on the exterior. It can be a containment on the interior. So we have no issues with any waterproofing, or at least our waterproofing, adhering to our 3D printing mortar.
Sure. And you said that you added some materials to give it some flexibility.
So um, there are, as well, when we're talking about flexibility, I, there's some there are some additives in the material. I really can't speak to what they are,
Sure, I understand
but
that.
also note that there are fibers in the material as well for flexible strength.
Yeah, that's interesting. I've heard some people say, just people in like comments of videos and stuff, that fiber in the concrete isn't enough to eliminate the need for rebar. Is that the case, or have you experienced something different?
Um, so we haven't necessarily done all the necessary assembly tests to really prove out one way or the other. Um, I'm not sure to what extent we'll be able to eliminate rebar completely. Um, the the things that I've read and seen is that the fibers or steel filaments that are placed inside a 3D print um, act more like safety glass. Like if you shatter the plexiglass, it's going to stick to it, but
Okay.
it's not going to break completely. So this is more what I'm understanding. I'm not a structural engineer, but this is more my understanding that it's going to stick together. It's going to have allowed to have fractures, but you're still going to need something to keep that completely from breaking, and that's where the rebar comes in. There are still challenges with rebar though. How it's placed, again, we're trying to digitally fabricate it. We've been focused on the extrusion and placement of the mortar, but the interaction together with, we are speaking with some reinforcement companies to work out these equations and how do we automate it. We have done tests as well as adhesion to rebar, but just remember one thing that when you're placing rebar in that wet water of convenience cement or concrete mix, it's flowing all around it. And now we're dealing with a more paste-like material, so you're not necessarily getting the same flow over that rebar. So even if you just shove it in there, it may or may not flow around it to completely adhere to it. So it's we're changing many variables at the same time.
Yeah, definitely. Nobody expects of like finished, fully polished product, really, I don't think, in this space yet. I think most people who are checking it out understand that it's so brand new that even big companies with a lot of resources don't have it all figured out yet. It's a learning experience, certainly. Um, and I guess you being a director of innovation, you're kind of on the cutting edge of your company's drive towards figuring out these new spaces. And I guess for other people, maybe it's not a top priority at the moment because it's not a primary source of revenue for your company yet. But you're in a unique position where, like, focusing on the primary source of revenue for the company historically isn't in your job description. You're kind of like a visionary for the company. So it's definitely cool you're the first big company that I've talked to that's actually really interested in this space.
So I definitely have to give credit to our founder, or our CEO right now, David Rothberg. He's the founder's son. Well, first of all, we're a privately held company, so this is part of his vision. He also sees this better, the working towards a better future for everybody. So improving the built world, improving the social responsibility of, again, the affordable housing and all of this. So there's a lot of avenues that we can take this. How much we're on the cutting edge versus bleeding edge is still to be determined. Again, if you see just in the past 2 years that I've been working on this project, going from the 10 companies to, or 10 really people, to faculties, 3D printing programs being established as set curriculum and universities,
Yeah.
Investor money from large corporates like Perry and Doka that see it as an existential threat. So there's definitely a booming here. So how much we're on the bleeding edge versus cutting edge is still to be determined, but it's definitely nice to work for a founder and an owner that really shares this vision and passion for just, okay, not everything has to be a clear ROI, and not everything has to, you have to rely on your gut for some things. And his gut, our gut is telling us, this is the future, and we're writing it. Laticrete's part of it. And, we're happy to work with others, but we have to come together to make the world a better place. As cliche as it sounds, there's no other way to really justify 100% to know, okay, this is the return. We're basically changing everything and changing it on the go. So it's fascinating time.
Yeah, you mentioned like environmental approaches to stuff. So I'm wondering, as far as 3D printed cement goes and concrete, is environmental concerns, is that important right now, or is just making a product work really well more important, and then fine tuning how to make it really environmentally friendly later on? What's the story there?
Yep. Yeah, so environmental is definitely part of our vision. There already is post-recycled content in our material. So we have byproduct materials incorporated in the formula, and we have recycled materials as well, other recycled materials. So that's already there. The next phase is, again, this reduction. So concrete or cement is very stigmatized. The biggest challenge is, again, the benchmarking of what we're comparing it to. Nothing else is used in the volumes that cement is or concrete. And then also think about full life cycle, all these homes that are getting destroyed because they're built with inferior materials. Start putting all this together, and we do really already, as is today, have a greener product, a more eco-friendly product. We have investigated looking into alternative binders, non-cement systems. We have looked at other fillers, so biomass or alternative to sand. So there are some options out there. This is where it does get a little more business technical, and because in other conventional products, everybody always says, yes, I want green, but then nobody wants to pay for it. And availability of supply is also a challenge when we're talking about post-consumer recycled material. That definitely varies from country to country. Local earths, local sands, if you were digging up the earth and modifying it. So right now we're still much more in this early development stage of, let's standardize something so we have a base and benchmark. The sustainability factors will come in. That said, unless we really see strong government support to fund environmental actions, so something like you see with green roofs. Germany is a leader with green roofs. Why? Because if it costs €5 a square meter to install it, they subsidize too. So in €3 a square meter is maybe where conventional roof membranes are.
Yeah.
So you get a green roof at the same or lower cost than you would a conventional roof. So obviously people will switch over, and then the other benefits trickle down. So you get a better insulated building, better water containment, less water going in the sewers, etc. So I think we're really needing to see a market driver to drive and push something like a sustainability agenda with 3D. And we've seen it with NASA already. So why not sustainability?
Yeah. So it seems like other countries other than America are kind of picking this up and getting more involved in it faster. And like you said, other countries kind of have more subsidies for being environmentally friendly traditionally than maybe America has. So how much does your company operate in around the world already versus in America? And for this industry, where do you foresee the primary markets being?
So Laticrete, to answer the first part, where do we operate? Basically, we sell into everywhere but Antarctica.
Okay.
So we're prevalent globally. We have about 20 business units around the world. Some of those are in key markets where we see 3D development. For me, there's three clusters that have developed. The first one and the biggest one, probably Dubai. So Dubai actually has a market pull from the sheikh who's made a vision and put a statement out there that by 2030 we're going to have 25% 3D printed components in building in Dubai. So we have a factory there. We're producing locally. We've localized the materials. So as much as we can produce with local Emirati sand, cements, etc., we're doing that. So that also is cutting down on the footprint. And the market drivers then, the other two major clusters, I would say, is the Netherlands and Singapore. Netherlands, even more so, that you're really seeing a strong collaboration between the government support, the universities and academia really coming on board, and corporate collaborations that are pushing and funding a lot of this. So when you get all three of them working together nicely, it just accelerates the technology. And then once you have this ecosystem and clustering, it's just one's feeding off the other, and development kind of moves exponentially. But 3D printing is going to solve different things in different regions. So, and building itself is also very different. So you look in China, for example, it's many more high rises and dense urban construction versus US with vast urban sprawl. Germany has a lot of restoration work, or Europe in general. There's still a lot of new construction. There's still a lot of single family homes. So it's a nice mix, and different standards, different codes. But Europe is also much more stringent on safety protocol on the job site. Productivity gains are higher in Europe. So they're much more focused on this digitalization and optimizing the construction process. So I think 3D printing is going to be a solution alongside others. But again, it's forcing the right questions to be asked in an early pre-design stage. So in Europe, we're going to see safety, productivity. In Dubai, we're going to see beautiful structures pushing the envelope as far as what can be done and what structures can look like and how they can be built. And in Asia, I think we're going to see more in the prefabricated realm, components or even maybe modular structures that are going to be shipped into the more urban centers of China, Singapore, Japan. But in the US, I think we may see, I think US is completely open. On one hand, we could see, and we are seeing, like investors like D.R. Horton that are an investor in Icon, the one you mentioned. So D.R. Horton, a large track home builder in the U.S., maybe their interest might be consumer customization. It's a growing consumer trend. I mean, we're just used to, oh, I don't want that. Think of Model T Fords, right, or Model A. But I don't want just black. And now consumers are just demanding, well, I should have a say in what my house looks like. I don't want to pre-sale just pre-buy just this generic track home. I want to have a say in it. So maybe that's where D.R. Horton is interested in 3D. It could also be for infrastructure. We're seeing projects in the U.S. like wind turbines being 3D printed. We're seeing potential use for bridges. Um, what contractor really buys into it is it's anyone's game. I think if they're prefabricated facade components, it's really open.
Yeah, definitely. And it's really impressive that you guys have achieved a compressive strength of 5,000 psi. I haven't done tons of material research, but most companies I've seen, even doing the 3D printed construction, they're not achieving higher than like 3,000, 3,500. And a lot of them are in like the 2,200 to 2,700 range. So at 5,000 psi, I'm not an expert, but it seems like at that point, especially combined with parametric design, you can really reduce the total material that you're going to need to expend. Makes a lot of sense in layman's terms.
Yeah, yeah. Hopefully, again, it's I think it's Peter Diamandis with this idea of convergence, that it's not really one single technology that's going to advance and disrupt everything, but you combine parametric design with what we can our rheological experience with 3D with cementitious mortars. Combine that development, combine the software, the hardware component, and suddenly we really have a complete disruptive solution.
Have you considered partnering with one specific company and having some kind of exclusive deal with them? Or is your focus more mass market?
So I guess I'll answer that two ways. So on the first side, our stance as far as printer technology, we're agnostic. So we don't necessarily have opinion either way, whether it's a robotic arm, 6-axis robot, gantry system, a Delta printer, whatever it is. We're open to extruding, pumping mortars, and having them be used for 3D printing. We're even open. So we've been developing a 1K system. There are other 2K systems out there, so 2 components with an accelerator being shot in at the nozzle, static mixed at the nozzle. We've been able to achieve basically all the build rates, the speeds, and structures that our partners have requested from a 1K system, so we don't see the need to really add the complexity. So then that's one side of it. So we want to stay open to the technology and kind of ride the wave to see what is going to coalesce, what's going to develop, and be the leader. The other side of that, we look for 2 things. We look for a printer company that has goals, a vision to make more printers that will then buy more consumables, our material, or a developer printing company that's actually going to be doing multiple prints, making multiple projects. So if you fit that criteria, then we're open to some partnership talks, be it how well and how much market control you have. We want the technology democratized. We don't want it to just be shelved by one company that said, I want the Dubai market, so I need to partner with Laticrete because they have a very incredible technology and the best mortar. I don't want anybody else to have it, so let's partner and then not really take it to its full potential. So we want to make sure that if we do make that commercial decision to partner with somebody, that it's really thought out well and it's symbiotic for everybody.
Yeah, that sounds wise. Is there a project or a couple projects you could mention that have used your concrete, or is that not public information yet?
Yeah, sure. We can. So I can share some pictures with you after as well. I think the biggest headliner project for us is the Dubai Villa. It's with MR Properties Development Group. It was completed back in December 2019, so last year. With coronavirus and everything, we haven't really made any major public statements about it. We're still actually trying to figure out the way to correct terminology. It's we believe the first commercial housing project 3D printed. So in commercial being that the house will go on the market and be sold. So we believe it's the first of its kind that's a representative. So the development project is called the Arabian Ranches 3. It's a massive housing project in Dubai. So that one is exclusively with our materials, working with the partner 3D Vinci Creations. So that's our big house, completely 3D printed, or the shell, the framing. The other two to highlight, in India, we're working with a company, Hamilton Labs, that is making prefabricated components off-site for 3D printed toilets. So there's a big problem in India with open defecation. The Indian government has put forth money to solving this by making more and more public toilets. They have, I forget what the numbers are as far as the goals, but they are on a mission to eradicate that everybody has access to public toilets, so that eradicate the problem. So we've been localized the material again for India. So it's produced at our facility in Hyderabad. And then another project, one of my favorites, is a pavilion that we did for an architectural exhibit in Columbus, Indiana, with a Ball State fellow. His name is Christopher Battaglia, and he designed this structure that is 110 unique panels that are interlocking, so there's no mortar or any adhesive binding the joints. It's just all in compression.
Sure.
But when you look at the structure, you'll see the amount of material on the bottom versus the top. The bottom has very small holes in the middle, and the top is these big voids. So it shows you exactly where you need less material. So it's completely structural sound installation. It's signed off on by several structural engineers, but optimized for weight. So a really cool example of how when design is allowed to be brought through, what you can achieve.
So you mentioned it's modular. How big is each module?
For the toilet project?
No, for the third one in Columbus.
So they're roughly, I would say about, the largest one is probably 1.2 meters, 1.3 meters, around there. Smaller ones are maybe 600 centimeters or something. So
Sure.
it's each one is just a panel. So they're there's integral rebar being placed in each one, and then it's right now it's deconstructed, so it's a temporary pavilion. So you put in a little quick foundation, place all of them, interlock them, and let it release it into compression, and then the structure's sound. You take out the cornerstone, have some structure, and you're able to deassemble it or disassemble it, and have those 110 panels stacked up. And we actually took it back to our facility, and we were hoping to put it up in the spring here, but with coronavirus, we'll see what the plans are.
Yeah, not exactly a priority.
Yeah, definitely not a priority project.
So that's with the same concrete material?
To be honest, I have to double check on that. So right now, we've been naming our formulas so we had M23, which was the first one it was the 23rd iteration of development that developed. And I'm not sure if that was the one used for that, but the other projects we're using, the one we used in Dubai was the 31, so M31. Now we are up to M68,
Wow.
which just is very comparable to the M31, but more robustness. It's easier to work with. That the water content and everything, mixing it, flowability, resistance to temperature changes, et cetera, is just an easier to work with product. But performance-wise, it's comparable.
Interesting. So of those 68 iterations, have you tested any like geopolymer techniques?
Yes. So we have tested some geopolymer techniques. Two things. So again, there are geopolymer classified materials, to my understanding, again, I'm not the technical expert, that are in the composition of our materials. So there are some, we could claim something there potentially. But the most common marketed geopolymer that I'm familiar with, it's the hardware is the main question. So you need to mix. It's 2 steps in mixing. So it's instead of just water and a dry mix, you have to mix a slurry of the one binder, mix another one separately, and then mix those 2 together. So you have multi-stage mixing versus even a 2K system where you have just the accelerator at the nozzle and a static mixer. This has actually, you have to mix substantial amounts of each. So you're doing the stage mixing, which just most printing companies that we've worked with aren't looking to invest or don't have, and so we just kind of stayed away from it a little bit for now.
Yeah, sure. That makes sense, how it's a more complicated mixing process.
But maybe you know, there may be very well maybe innovations there that we need to look closer into.
Have you guys considered insulation and how to tackle that challenge? I know that some of the flooring materials you have insulatory properties, and that's something that you guys have a lot of experience in. A lot of companies that aren't focusing so much on materials have just like used foam blocks or spray foam or something. What are you guys thinking about?
So right now, as far as insulation goes, we're kind of passing that to the designers and architects on the project. We have talked about working on a project that would be doing multiple things at the same time. So while you're printing, also applying some insulation. That's in works. We also are banking on the idea that some insulatory properties will come from the design itself. So thermal breaks, for example, could be easily implemented into the design of the wall structure and give you the at least some of the added insulatory requirements. So we don't produce insulation, and we're happy to work with others that want to either apply it at the same time, spray it in. The market right now is at a stage where, again, it's collaborative. So we really need everyone to say, okay, this is my intention. This is where I'm, my expertise. Insulation is not our expertise. But if somebody wants to work to come up with that, again, this push button future vision of where 3D is, and say, all right, well, we really need a material to do X to then adhere and place the installation in the same sequence or in a sequence with the 3D print. We're happy to work with them to do that.
Yeah, that makes a lot of sense. You can only allocate so many resources to something that's not really cash flowing so much yet. So I think it's smart of you guys to really focus on being a material specialist instead of diluting your focus too much.
Yep. Yeah, and we also just that's that's what we have. That's what we produce. It's a blessing and a curse because there's so many technologies out there that I'd really love to dive more into. You got guys in Australia 3D printing with hempcrete. You got Wasp in Italy using local soil and grinding it up. Even people using thermoplastics. There's what's it called? Dimensional 3D, I believe, in Houston, where he's using spray foam as a positive mold. So print the foam and then infill it with your wall. So kind of a exoskeleton, if you will, kind of a reverse of the traditional.
Uh-huh.
So yeah, there's a lot of cool emerging technologies, and to figure out behind the marketing spin of all of them, it's definitely a challenge.
Yeah. So I looked into some of the previous content that you've done around automated construction, 3D printed construction. Your position being focused on innovation as a whole, what other branches of innovation besides 3D printing have caught your interest?
So definitely anything with automation. There's a couple startups looking to automate the application of our Hydroban, our waterproofing membrane. There's a startup speaking in, excuse me, we're speaking to about the installation of our resinous materials. So getting automation onto the job site, or even in a modular setting, in a factory type setting, we'd love to keep moving forward with that. As far as the tech stack, on the digital side, this is another major focus. So there's a lot. If you get the opportunity to come, right now we have everything online with Laticrete University. In the past, we've done a lot what we call profit through knowledge. So we have these things, PTKs, that you come in, you meet our technical service team. The amount of knowledge that's sitting within Laticrete is incredible. We have specialists and really a field that underappreciates just how technical it is. I mean, we joke we put dirt in a bag, and at the same time, the different backings of a tile, the different textures, the different ambient conditions and all these changes, how they're interacting, what's needed for local climate zones, how it plays into the acoustical environment, or the thermal value, or the heating. So we have all these incredible technical people in the company, and each one has either written or produced internally so much just knowledge about how our products interact with the built world. But it's really hard when we don't sell the product directly to the architects, designers, and even them, for them to take the attention of every product. There's thousands and thousands of products in a construction project. So to learn about what's happening at each one on that micro level and how it interacts with the other ones, this is where I'm really excited to see what's the future of construction. I know BIM has been, people have been talking about it for a long time, that these future dimensions of BIM. Right now, again, it's being used a lot for making better 2D drawings and less for actually, well, it's being used for clash detection, it's being used for some other things, but to its full potential of really how a material is going to improve the entire building, it's not there yet. Some people are sort of using it for it, but working with various software providers and companies, there's a company in Israel, that a startup called, they were called Bauhub. Now I think they're called BIM Match. And BIM Match vision is basically to take BIM and make it into a product selection and procurement tool. So if you have something like that, where now you're choosing a premium product because it's really giving value add attributes to the home, this is kind of our dream of, at Laticrete, we've developed all this really cool stuff that actually provides value, but to actually get somebody to understand how it provides value, it requires someone to really geek out about dirt in a bag. So it's a very challenging matchmaking to happen, and a computer doesn't care. So this is where it's exciting to see that in the near future, we're going to have technological solutions to really push product selection to a whole nother level. And it's just cool to work for a company that actually has great products to put out there. So.
Yeah, and clearly great philosophy and core values to be forward thinking enough to devote full-time people to projects like this when they already have other profitable sectors that they could focus on instead. So I guess it's really a testament to the longevity of your company. Like, you're not going to get Kodak'd where some new technology comes along and it completely blindsides you. You guys are already focusing on things that are like outside your existing wheelhouse a little bit, expanding your horizons. That's really cool. It's definitely a totally different position than most of the companies thinking about this space are in, because you guys have so many like tenured people that are very experienced, probably been at the company a really long time. You've already developed the like management techniques, and your company's like softwares and management and everything is much more like sanded down and fine-tuned than some of these startups that are just like scrappy, trying to figure out everything like day to day. You guys are definitely in a more experienced position. And of course, that probably comes with the drawback of kind of being a little bit more slow moving. But the fact that you're a private company instead of a public company, if you guys and your founder and your CEO wants to do these innovative projects, nobody can really tell you that you can't.
Yep. Yeah. And again, we're lucky to have leaders that their gut decisions with 3D, for example, their gut decision was several years ago, and now everyone's joining into it. So it's not just the support, but it's also the vision to see what's coming in the future.
Yeah, it's really cool too how to some people, a company like Laticrete that's making construction materials, like most people, like you said, don't get excited about construction materials, even people in construction, because there's so much going on. But when you start talking about something like this, like automated construction, it becomes almost like a sexy startup entrepreneurship kind of thing, instead of like dirt in a bag, like you said. Like, it's a totally different kind of like being on the cutting edge, being on the bleeding edge. Like, it's hard to picture the bleeding edge of flooring products and stuff like that, but it's easy to picture the bleeding edge of 3D printing. And so, especially from like a general public's perspective, that really makes your company look forward thinking and like adaptable compared to companies that are kind of maybe putting out a little promo video about 3D printing. Maybe they bought a printer and they're like doing some test prints, a pillar, whatever. But they're not really diving into it and investing their valuable human and financial resources into pushing the technology forward like you guys are.
Yeah, no, it's thank you. I guess it's definitely a fun project to be on. It's really, and when you see stuff like Fast Company or Forbes and other big periodicals and New York Times pushing 3D construction printing and talking about it as the future, it's definitely cool to be part of the future, part of this trend that's happening. And we're really only scratching the surface here in this interview, because we're still talking about only the construction phase of the built world. We started talking about a little bit the design phase with something like the D.R. Horton, and the consumer actually having a say in how their home, the future home, is going to be built, and being able to drag and drop and easily know, okay, well, this customized design is going to cost me this much more. Then you go a little bit forward and talk about the post-built. So now you're getting other players coming in interested in what we're doing as well. So you have insurance brokers, again, that house in Florida that blew over, or the one that didn't blow over. Imagine once the actuary tables are updated to really show the benefits of the 3D printed house as a better product. I was watching an interesting documentary that was separating or highlighting how much we need to separate the land versus the house as we group them together as one value, one financial product.
Sure.
But oftentimes most often the land is appreciating, the house is depreciating, and the hope is that the land appreciates enough to offset how much that house product depreciated. Because basically most houses are falling apart. So we're talking about building houses, for I don't want to say indefinite, but we're talking about building for a very long foreseeable future and a much premium product. So and a customized product that brings all these extra added values to the people actually living in there. So combine all this emerging technologies and demands from consumer side and property managers, insurance, even people like furniture manufacturers. Maybe IKEA wants to know if you knew exactly how big it was from column A to column B without having to measure, or if the as-built is equal to design, you could just easily send to IKEA, oh, well, this is what I want in my home. And they're also going to have digital fabricating solutions. So you're not going to order an off-the-shelf bookshelf and hope it fits. You're going to order because your house design is going to be in some repository, and the post-consumer customers like IKEA will say, okay, yeah, here you go. This fits exactly to the dimensions of your room.
Yeah, it's a really cool concept to introduce customization to mass market products. Like IKEA always shooting to provide the most value. Often they'll sell like so many of the same desk or the same chair, or like the LAC table. So many people use the LAC table as like a 3D printing enclosure or tons of stuff, but it's the same table every single time. And it's great that it's $20, but like if you walk into someone's apartment and they have like stuff from IKEA, it looks super obvious. That's not a problem for certain people, but other people are going to have an issue with having something that's so identifiable and not customizable. I think you're right. Companies like that are definitely going to be interested in this technology so that they can start to reach into that customizable market more. It's from the software perspective, like you were saying, it's really interesting how you said like drag and drop. That seems really cool to me. If there's some software where a person can go on it and kind of drag and drop their whole house together, maybe like decide the wall size, how many bedrooms, bathrooms, whatever. It's going to be really cool seeing that technology ultimately come to fruition. I have no doubt that it will. It's just a matter of whether it's like 5 years down the line, 10 years down the line. Yeah, it could be really cool. And that's such a big topic to go into.
Just think of, I know Uber is the cliche when talking about new technology and everything, but you never really thought about, well, what's the name of my taxi driver? What route is he going to take? Do I have a say in that route? Estimate how much is this going to cost and evaluate your other options. So now you can easily, okay, I can toggle between Uber and Lyft. I can look and say, okay, well, I'm 3 people. It's going to be a $12 ride to get there, or $2.50 if we take the subway. So it's the amount of information in the consumer's hands has changed dramatically, and it's influencing other decisions. So it's to me, it's an inevitable future outlook of construction.
To take that analogy even further, like Uber will tell you the cost for an Uber Pool, an Uber X, an Uber Black car. And so you really see the full value network behind what's going on. And it's like the BIM software you were telling about, where it could be like, here's the stick built cost, here's the CMU cost, here's the 3D printed cost. And that's when it really starts to become huge added value, because it's like it's almost like that Progressive insurance commercial where it's like, we show you all the rates of the other companies before you choose which company to go with. That's a huge added value from a consumer's perspective, because most people don't have the construction experience to really understand when they're building their house what materials they want to choose. And maybe they're just going with their contractor's experience or whatever they say. But the general person doesn't have time to do all the research into these things. So having a software that allows them to really see what's going on adds huge value. There's so many people who want to build a custom home. That's like almost part of the American dream.
Yep. Yeah, and we're going to see it with so many other products. I mean, if you look at something like our floor heat, it's electrical floor heat that's under the tile.
Okay.
And it can be ambient heating for the home, which can also mean ambient heating for a hospital or some other place. That means no forced air contaminating room to room. It also means that you have complete control at the flip of a switch, where and what is being heated. And we already have it. It's a product we've commercialized that you have a geolocating thermostat. So it connects to your phone. It knows what rooms you're in. It also can tell if you have a certain routine. If you're on the way home and you're stuck in traffic, it can delay the heating to turn on, and you're not wasting energy. So we already can prove that with the combining the technology with the integral electric floor heat, it's called our StrataHeat system. You can then reduce your heating bill versus forced air solutions. So it's
that's fascinating how the air contamination idea. I didn't think about that at all, but I guess is it radiant heat floors?
Yep.
So having those radiant heated floors and removing the need to have the air flowing, that's huge. It seems like, I guess currently hospitals sterilize the air.
Yeah. There's plans of airflow from room to room and where it goes, and sterilizing it, filtering it, whatever they do. They control the circulation for sure. And you're still going to have some circulation. You open a door, you open a window, you're going to have cross breeze and this and that. So you're still going to have air flowing and still going to need to plan it. But changing just one thing like that again. But what I'm trying to get to here is that this is where the parametric design really shines. Because right now it's expertise that are sitting with some guy at a desk in Laticrete, and not to explain it to each architect. It seems nominal. I mean, that one might be a little bigger, but a lot of these little innovations that we have sitting in our product portfolio, it's really hard to educate the market. It's the same. Imagine a doctor, right? They go through, I think it's one semester of pharmacology, and every month there's new drugs being brought on the market. So it's kind of an unrealistic expectation to expect a doctor to know the interactions of all these drugs. So you look at that in construction sense, and the architects, the designers are out there. They learn about how products perform. There's so many innovations happening all the time, and to re-educate them constantly on what's happening, it's just an unrealistic expectation. But when you take in parametric design and you can really start quantifying, okay, this is what's the benefit, and not just the health benefit of living in that space, but then again, taking a look at insurance rates or heating bills or other things that are going to come when someone's actually living in that home. Now you really have a very strong argument for premium building materials.
Yeah, when the software is developed to like kind of the level that we're talking about, there's going to be huge value added, especially if the software can do some of the structural engineering calculations and maybe even help with the construction documents. That would reduce costs, reducing the cost of the engineering, reducing the cost of the planning. And I don't know if companies are really factoring in that value added yet in their calculations, because I don't think there are companies working on like a click and drag solution really that would give you like a structural analysis. So like the software still has to catch up to where like the hardware and the materials kind of is getting.
Yep. Yeah. What do you index it to? What's your benchmarks? So you need the software. It right now mostly in construction tech is focused on productivity and safety. And productivity is really just saying how well do you hit the schedule. And it works best with unitary things. So there wasn't a toilet there. It's binary. There wasn't a toilet there. Now there's a toilet. And time elapsed was 3 days. So does that mean that it was 3 days to install a toilet, or did they come 5 minutes before the screen happened, and it took 5 minutes to install it? But on the progress chart on the project, it's showing 3 days was the time it took to do that item. So yeah, there's still a lot of development that needs to be done in the project management. Again, this idea of constructibility. There's a lot of interactions that need to be built out that we're still not there yet. But there's thousands of construction startups. Autodesk is hosting a lot of them in their incubator spaces. There's definitely a lot happening within construction tech.
The benchmark that I hope to see at some point in my lifetime, I'll imagine I will, is a software combined with a functional hardware, so that like a kid, like maybe a 10-year-old, could use the software, click and drag a house together and press go and have it be printed. I mean, that would be like the gold standard, and have it be like foolproof. I don't know how realistic concept that is in my lifetime, but I would have to imagine it can't be more than like 10 years away with all it seems like most of the really difficult advancements have been made. Like the parametric design software has been developed, and now people just need to like master it and do parametric designs that are capable of kind of like figuring out these efficiencies and calculating different methods against each other. I definitely need to learn more about parametric design and maybe have a conversation like this with an expert on it, because everybody I talk to in this space always brings up parametric design, and it's such an integral part of the developments here.
Yep. Yeah. No. I'd love to watch that. Let's say I'm definitely not an expert or really know much at all about parametric design or regenerative design, but it clearly is the future. I mean, you look again at the pavilion we built with Chris, and it's just evident right as soon as you look at the picture that this structure has something different about it. And that was just one example. And you start applying that, and then when we start talking about mass scale, then it really is it's cool. It's the future is closer than we think, though. I mean, there's already companies that are doing autonomous excavation. There's full operators that are working remotely to operate diggers and other construction equipment, autonomous cranes. So all of these technologies that are making their way on the job site, each one is collecting huge amounts of data, and with each collection or each company that comes on, they have their mission, right? So maybe the mission of what is it called? I'm drawing a blank on the name of the company, but there's these productivity softwares that basically again match up the BIM model and the schedule, the project schedule. So did it happen on time? A, B? Yes, it did. That's the data that they're contracted to provide. So they give that, right? But in the same exercise of collecting that data to determine whatever happened, they also collected thousands of other points of data. And indexing this correctly is where we're really going to start to see a trend happen that people are going to start to identify, okay, well, this is a pattern, this is a pattern, this is a pattern, and suddenly we'll have many more answers of how to bring construction solutions to the job site.
Yeah, data is like, of course, always so important. And as a bigger company, you guys have the wisdom to be able to collect and analyze that data probably more effectively than the startup might be able to. You probably have people dedicated, like data analysts, data analysts.
Yeah, yeah. So again, it just we do have data analysts on staff. The question is really, what data are we talking about? So we're going through a transition as well, where we would identify, I believe, most people at Laticrete, well, maybe we should do a poll. Most people would say we're a manufacturing company.
Okay.
So we push towards operational efficiencies of production and logistics to get our materials to the right person just in time. So that's our core competency. I mean, we do very well in the selling process as well. And that's another whole thing of data. Then you start talking about installation. And yeah, when I first started here with the director of innovation, I had that thought of, okay, how do we collect installation data? So we do have a provisional patent on an idea for a smart tool to collect data from the job site. So we're also very much interested in the installation side of getting, again, just more data, but it's not just collecting data to collect data's sake is not really the goal. The goal is actually to improve productivity, improve how users interact with our materials. So it's indexing. This is the devil's in the details. So it's easy to collect the data. It's hard to actually have it structured in a way that can yield more results. And that's really the big challenge of the future for us.
Yeah, that's like a classic modern day issue. If printed construction took off and became a significant branch of Laticrete's operations, do you see yourself kind of transitioning to a position that would focus more on that? Or would you kind of stay in an innovation position worrying about what's next? Or are you personally invested enough in printed concrete to want to stick with that?
So yeah, it's a great question. I'm actually discussing internally as well here. My personal opinion is that I'm not the technical expert, and my expertise is more on the strategic side. So I'd be much more inclined to be the person overseeing strategic planning, the business side, incubating these ideas. We don't have a venture arm currently, but potentially something like this that's the venture arm. And I don't see 3D printing as mutually exclusive to have to be a technical expert overseeing just a 3D printing company or 3D printing, offshoot, whatever it is. Because I see 3D printing as this, it's one tool in a digital fabrication repertoire it's forcing the digitalization of construction. So because it's digitally native, because you have to have all the designs in place, you have to start asking this question of constructibility at an early stage. It's a great proving ground. It's a great litmus test. It's sort of just pointing construction in a direction. And then as it grows, other things are going to come along with it, right? So just the talk we just had about the floor heat. So once you have this better built out computer model, now Laticrete's not just focused on 3D printing. 3D printing will become, I don't want to say commoditized, but it will be a standard product that will have all the things that go along with that. So branding, marketing, production, making sure that we're continuously improving that product, and logistical concerns of where it's being produced, how it's being produced. So all of the standard day-to-day business operations that are needed to keep that product going will still be there and still be needed. So there'll still be a team dedicated to that, and it will fold into the business. But I would see myself much more in that visionary side of, okay, well, now we understand how to optimize the supply chain with 3D printing. What can we do with flooring? What can we do with exterior envelopes? And what can we do in tile and grout? And so I would see myself more in that area.
Yeah, that makes a lot of sense. That's a cool insight into what the future might look like for you.
Hopefully. I love the idea of 3D printing. I'm hoping you're one day soon that maybe my son is 4.5, so maybe by the time he's 10, he'll design the home that you're talking about.
Yeah, that would be really cool. That's a short time for him, but it wouldn't surprise me at this point if someone made it happen.
It's everything. I mean, when you think back, to where the iPhone was 5-10 years ago, or just little things. When you really look back, I mean, watch a movie from early 2000s, or the 90s, and you'll be shocked at just how much our lives have changed. And it's kind of the boiling frog thing that you just don't notice the extent. I mean, for me, I was geeking out. My son, actually, what's today? May the fourth be with you.
Okay.
My son changed the lights to be activate the Star Wars, and that turns on the lights. So it's just a 4-year-old having this interaction with a virtual assistant, and telling it to play stuff on the TV, or he I think when he was 3, maybe he was like just turned 3, and he could open my phone, find something in a folder, open it up, and play with it. And it's just crazy. So that's the norm. And imagine when that comes into, hey, well, I need to buy a house. It's going to be why would I buy just this old off the shelf product that doesn't do anything for me?
Yeah, definitely. That's a great point of how like younger generations are kind of growing up with all this technology, and they're like definitely more open to automation, and they're excited by automation, and a willingness to learn, and I guess the maybe malleability of a young mind to be exposed to these innovations. It's really going to be a powerful thing when these young minds grow up and start like dedicating some of their mental energy to solving problems that people that have been kind of like stuck in old ways have been challenged with in the past. So with your son, do you expose him to some of these emerging technologies like 3D printing and stuff?
Yeah, so I'm working on a solution for smart flooring. We put together a little mat that would go under his carpet. Again, Star Wars themed. We programmed it just to play a song when he would jump on it. So
Cool.
he was having fun, like lightsaber when he'd jump on a certain spot in the carpet. So that was a fun little exercise. So I don't think we can avoid technology. I don't think we can run from it. To me, we try to limit it. We try to balance. I think there's good tools and good programs, be it software technology wise, or blocks. For me, what I look for with my son is that his creativity is not capped. So if it's blocks and he can, Legos or something that he can do and make it his own, or that computer program that also allows him the freedom to experiment. I'm not a big fan of this education that's just root memorization to do exactly that somebody else did. That's I love the creative mind, and yeah, my son definitely teaches me a lot of just how flawed. Try to teach him English, and uh, with how do you spell this word, and it starts with a K or a C, and it's like, why do we have the same sound? It's really really confusing when just all these norms that you don't realize. Or my favorite was the yellow orange juice. It's
Yeah.
it just like hits you in your face, and it's like, okay, well, I can't argue with that. That's flawless logic. But for me, the bigger challenge when you talk about technology and bringing it into construction is we're talking about two different product life cycles. So we just spoke about this beautiful building that's going to last forever, and then integrating all this technology in it, or especially when you talk about IoT. Now we're talking about a 2-year life cycle and integrating it into a lifetime product. So that is something that's going to have to be worked out in the construction space. I mean, when you go to look at Switzerland, what they're doing with the DFAB home at ETH Zurich, this is something that's really avant-garde. Of okay, you have interchangeable modules, and you can switch things out, and the building is flexible. You see the same thing, the growing trend with smart cities of, okay, we have to have an adaptable space. So it's going to be it's easy to bring these things in. It's going to be harder to keep them relevant. And if the assumption that certain real estate land-wise is not going to change, then we really need to figure out a way to bring continuous improvement into those spaces. If you look at what's happening now with COVID-19, maybe we finally found a reason to justify all this urban sprawl, but we'll see which way. And there's also customer preference, but yeah, it's just going to increase. There's no, in my opinion, there's no real stopping it.
Yeah, the urban sprawl is an interesting point. I know that there's like unprecedented levels of people kind of moving out of cities right now. This kind of technology in construction seems to me more applicable in suburban and rural areas where there's more open land, rather than cities where you have to do a whole demo project and then build potentially really close to other buildings. So I think the urban sprawl is probably a benefit, or will add positively to automated construction rather than detriment it. But yeah, we'll see if that's a lasting trend, or maybe it's peaking like right now.
We'll see. I mean, raw material wise, demolition provides a great source of so cured out concrete. Old concrete has already sequestered carbon in it, and it's one of the it's harder than most rocks, so it continuously cures as it ages. So if you can find a way to destroy it cost effectively, reprocess it, and reproduce it into another 3D printable mortar, then you have a great feedstock. So not to say that urban revitalization is not also a great strategy.
That's a great point. I never even thought about that. The recycling concrete not only is a valid option, but maybe offers some benefits.
Yep. Yeah. So this is where I'm going to butcher the terms, but the main school of thought when we talk about environmentally sustainable construction is in this idea of, I believe, embedded properties of the materials. So, it's on the production side. So you think, okay, well, it took so much carbon output to get here to produce this, and there's off gas, this or that, right? But the embedded factor, and this is the long-term vision, concrete's a recyclable material, and you can basically recycle it on the job site. So it's not this overarching horrible material that everybody says that it's stigmatized as. It's continuously sequestering carbon as well. So it could be very much part of an integral holistic solution towards a sustainable city.
It's almost deceptively recyclable.
It's a repository for carbon. So
yeah, that's a valuable attribute. It's tricky to measure how much carbon is stored in it, or is that like do you know off the top of your head?
That part I'm not sure how you actually measure it. There are some interesting startups though in this space as well that are actually getting carbon CO2 cartridges from companies like Airgas and incorporating it into ready mix. So and to do just that, to sequester carbon. But all concrete materials are also having this carbonization as they age, that they're continuously absorbing more in. So I don't know how it's actually measured, but it is, one of the benefits of the material.
It's continuously absorbing more carbon.
Wow. As far as I understand. So yeah, the process is called carbonation, and it's as far as I understand, it's still absorbing. So when you break it up and recycle it, you have potential to lose it unless you reincorporate that into future mixes.
Sure. So I guess it's a tricky calculation to figure out if the sequestered carbon equals the carbon that's released while it's curing.
One more time. So is the carbon out sequestering larger than the carbon cost of production?
Yeah.
Yeah. Yeah. So I'm in no ways the expert to answer that. So our scientist, Dr. Kovarian, he came from a company called Solidia that could shine more light onto that. They've also invented new ways of producing a lower carbon output product, cement, and production of blocks that is of lower in the complete carbon footprint. But yeah, they would be much more apt to answer that question.
Sure. Let's see. Is there anything else you'd like to touch on?
We talked for a little while here. Nothing off the top of my mind. Just really, I hope this comes off as inviting to everybody that's listening, that we're happy to bring the Laticrete's rheological expertise and the chemistry side, material side to the equation. And we're working with partners around the world. And we're in this together, not just COVID-19, but making sure the future is brighter. And, let's make it a collaborative group effort. So I think it's a win-win for everybody. So I hope people that are listening see this as an invitation and reach out to how we can work together.
Sure. Another thing I wanted to ask about, in the beginning of this, you mentioned an online education system that you guys developed over the years that's now becoming really useful. Could you go into more detail about that?
Yep. Yeah, so it's a hosted online learning platform called Laticrete University. It's free for anybody to sign up and join. Just go to our website or type in Laticrete University. We have over 100 modules on there, everything from tile one-on-one, the basics, what is resonance flooring, through to product-specific learning modules, how to install our Hydroban waterproofing, tips of the trade. So it's made by an ex-installer, so he knows firsthand, Steve Rampino, he knows exactly what are the average downfalls. He's been a teacher for Laticrete for 10 plus years, doing in-person trainings. And it's just a really good online tool. We see it a lot with people using it for onboarding of new employees, and not just the contractors that are actually installing the products, but distributors that are having to sell the products. How do you talk about a premium product? You know, if this tile adhesive costs $8 a bag, why would somebody pay 20? There's definitely reasons why, but it's hard if you don't know what you're talking about. So stuff like that is a main driver. Architects are also a big user of the system. Again, keeping abreast of what's happening. We also do have hosted on a third-party site continuing education training modules that you can watch. So you can get architectural credit for watching some of those. But we're, again, looking to expand it and then do a series of webinars as well.
Yeah, there's major added value there for sure. I'm sure, like, historically, you guys had to teach people how to install different projects and educate them, maybe face-to-face even. And so the time saved when you can just send them a link versus sending a delegate or a salesperson is astronomical. And also to provide that for free online opens up the space to a lot of people that maybe otherwise wouldn't have had access to, like, expert information. I love online learning, and even like when I was in college, so much of what I learned was from YouTube rather than the way the professor taught it in class, just because sometimes a video like that can just be a much better way to, like, pace the learning. You can skip sections you already know about. You don't have to, like, I mean, in a classroom setting, they're kind of teaching to the average student. So if somebody wants to go a little faster or a little slower, that's not an option. But with a video, they really have full control over their own learning experience. So yeah, the fact that you guys did that 4 or 5 years ago before all this went down, I'm sure now you guys are really glad you did that. It's paying dividends in your ability to share information just in general.
Yeah, for sure. So having people be able to watch it at their leisure definitely helps, especially now with COVID-19. The reality, though, is we're not seeing it as a replacement. You know, even though we could easily say we've trained thousands of people for the same price of training hundreds.
Yeah.
The reality is we look at this as supplementary. So if you took this and have a basis, and then you get the in-person training, now you really have a step up, because you're not just going in blind. You take the online learning course, and then when our rep comes out to give you a demo, you have a frame of reference to ask the right questions, or you can always dig deeper and learn more, but just having some basic understanding really helps.
So if you were to take a shot in the dark on when the first learning module will come out on printed or automated construction, when do you think that will be?
Let's say 2021, next year.
That's very soon.
I think there's definitely companies we're working with that are very progressive. And there's also software companies that we've been speaking with, like Wrap Technologies, that have a very similar vision of let's start capturing all these variables and what happens. So it's not just, okay, me doing a test that's saying this is the amount of overhang I was able to get, but to know, okay, did we cantilever the 3D print? Did we, what was the ambient conditions? What was the temperature? What was the humidity? What was the print speed? What was in it to do a finite analysis? The vision's there. So once we start getting enough mass, maybe by late next year, we could start doing converting the 3D desktop printer to use cement materials. Could be a fun module to do, and I think the technology is almost already there to make it where it's somewhat off the shelf.
That's really cool. That's an exciting field. I would love to try to do something like that myself and convert my printer to be able to print cementatious materials. If I had the time to do that, that could make for some really great videos too.
Let's connect you with Co, and he can walk you through what he did. You got a lab pump and mixer and everything, and it flows. It works just like it's a small scale, but it works. And then a 50-pound bag will last you a little while.
Yeah, that's pretty cool. Portland cement? When you say 50-pound bag?
3D printing mortar. So there's cement in there, but yeah, Laticrete 3D printing mortar.
So it's like so it's an all-in-one mix.
Yep. Yeah, ours is a 1K system. You just mix with water.
Cool. Very cool. You don't have it commercially available yet, do you?
To some degree, yes. We can get you the material for sure.
Kind of like a special order kind of thing.
Yeah. It's there's still too many open variables to say it's fully commercialized.
Yeah.
But so let's say we screen the people correctly to know that how it's going to be used, and then sell the material.
That makes a lot of sense.
But yeah, for sure, you can, if you want to convert your 3D printer, we'll keep it stocked.
That would be awesome. I'll definitely look into it. I don't know how big of a project that is and when I'll have time to tackle it, but I would love to.
Sure. We got a special guest here in the show.
Hey, dude.
So this is Itan.
Hi, Itan. I'm Jared. Your dad's been really nice talking to me for almost 2 hours about automated construction, when I'm sure he has much better stuff to do, like hang out with you.
Yeah, he's a little shy.
I really appreciate the time that you're giving me right now. It means a lot that somebody from a bigger company is willing to talk to me, just kind of like an independent journalist kind of guy. I think that the information you shared with me is pretty valuable to people. And when I put this on YouTube, they'll be able to get the value out of this conversation that I did, and you won't have to have it a million more times. So hopefully it can have a similar effect to like the online education thing and save you some time.
Awesome. Yeah. Let's spread the word. We're the more people that are talking about it, the more that's going to happen. So it's one thing to just be ideas. So let's actually make it happen.
All right, thanks. I'll definitely be in touch with you in the future, whether it's over the desktop printer project or whatever it is. You guys are working on so much cool stuff. So I look forward to maybe we'll have another conversation like this one day.
Perfect. Thank you. Have a good night.
Yeah, you as well.
Bye.
If you enjoyed this conversation, subscribe to my channel for more content related to automated construction and 3D printing in concrete.